Welcome everyone to the third of our four-part TPM webinar series. I am Rose Capshaw from Tooling U-SME and your moderator for today's session. For over 90 years, Tooling U-SME has promoted the advancement of manufacturing by supporting new technology and industry and the development of its workforce to sustain manufacturing. We hope you enjoyed today's topic on prioritizing maintenance. You can sign up for the remaining topic on maintenance culture on our website at learn.toolingu.com. You will notice on your screen there's a Q&A box where we would love for you to hear your feedback and your questions or comments, which we will be able to look at the end of the webcast. A recording of today's session will be made available on our website at learn.toolingu.com. Also on your screen, we have our facilitator's bio, and it is with my pleasure to introduce you to our facilitator, Drew Locker.
Thank you, Rose, and welcome everyone to our third webinar. First one was on predictive maintenance. Second one was on autonomous maintenance. And this one, I hope, helps organizations figure out where to start. How do you prioritize? Which isn't always straightforward and obvious, particularly if you have a lot of equipment in your facilities. So we've got some content to go through with the presentation, and my hope is that we can have some good conversation at the end. We'll have plenty of time available for that. The first webinar was great. I mean, everyone was contributing in the chat, what their experiences with predictive maintenance. The second webinar, I don't know if we had any contributions there, so we ended it early. So hopefully, you guys are willing to share your experience. I'm a firm believer you all, while we're all together, we can learn from each other, not just from me as the presenter. So the subtitle of this webinar is Beyond OEE for Smarter Decision Making. So I don't really know who's attending these webinars and what your experience is. So we're going to talk about overall equipment effectiveness, or OEE, and then I'm going to move on to another way of looking at this in terms of using data to help prioritize where you need to focus your efforts on this topic. But we will cover OEE and then talk about other concepts beyond that. Okay, so again, this is the question that I often get from folks, where to start. We usually will do an event or two applying what I would call total productive maintenance, which includes all the subjects that we've covered in the webinars and more. That gives them an idea of what is required and also the benefits that they can expect. So at that point, they're kind of sold on the idea, and then it's like, okay, let's roll this out. So then we have to have a good conversation on where to start, and it surely, frankly, should be data driven in that discussion and those decisions. So some general guidelines. Think about your greatest business need or needs. So maybe we're losing business, potential new business, because we don't have capacity that we're losing due to excessive downtime. And what a great place to start, because you can leverage that freed up capacity into new business, and that can have a major financial impact on an organization. So now maybe it's not so much the lost sales that we're turning away due to our lack of capacity, but maybe we have to work overtime in certain areas on certain equipment because, again, of downtime. So again, that could have a significant financial impact. Probably not nearly as much as if we can gain more sales. That's usually the big cha-ching for organizations. Now, what I try to get organizations to understand is to distinguish between the value of machine time and the cost of downtime. Those are two different things. When I talk to organizations and say, what's the value of machine time? Well, I have an operator that's sitting around waiting, the maintenance person, there's maybe parts they have to get to repair the machine, and we have to expedite those in. They're looking at it from a cost standpoint. What you really want to look at it is from a value standpoint, the value that additional capacity can deliver. Again, assuming we can sell that capacity, and many times we can. From my experience, and I think it's pretty clear, the value of machine time is much greater than the cost of downtime. And that's why I kind of said a moment ago, that's where the real cha-ching is for organizations. And that also will help organizations make more informed decisions in whatever investment that is needed. We'll talk about this in the fourth and final webinar about developing a maintenance excellence culture. But there's an investment that's going to be needed in time, and training, and materials, and parts, and so forth. And a lot of times, organizations, when they only view it in through the lens of the cost of downtime, they tend to not make proper decisions. Yet, when they view it from a different perspective, the value of the machine time that it can create, that we can sell, all of a sudden the decision making changes greatly there, and all of a sudden these are worthy investments. We're not going to get into this a lot of detail, but I just want to always like to try to throw that out there. Really understand what the value of your machine time is, and not just focus on the cost of downtime. Hopefully that's clear. Because that can also inform you on where to start as well. Maybe there's some equipment that we don't have good margins on, and there's not a lot of potential new sales. So maybe we don't start there. Let's look at other equipment where it's different. The growth opportunities are there, the margins are there. That's probably where we want to start. We can also, talk through, and this is how we do it. We kind of talk through it as a group. Where is the instability of the equipment having the greatest negative effects, like safety issues? Unreliable equipment typically creates safety concerns. So there's can't really put a dollar value on that. People's health and well-being, though you can, but hopefully we don't have to get to that point. Maybe where equipment where we're really struggling meeting the schedule, and maybe that's turning or results into poor customer service, like late shipments, things like that. Or and this is an economic impact as well. Maybe we have to carry excessive inventory because we're trying to buffer that downtime on certain lines, certain equipment. We kind of buffer it to maintain our customer service, but at the expense or the investment of excessive inventory. There's a very strong relationship between reliability and changeover. I don't know how many times I've gone into an organization with the intention of working on reducing changeover on equipment, and very quickly in that effort, we'd have to kind of call timeout and pull the plug because the equipment was just so unreliable, so unstable, that we have to change our focus from quick changeover to improving equipment reliability through TPM. So there's a strong relationship. So I often will talk to in these conversations, ask, tell me where you have lengthy changeovers. Is it associated with the poor condition currently of that equipment? And a lot of times that at least leads to some meaningful conversations, but usually it's the case. And of course, you can always look at where we're creating a scrap and rework, which could be, again, related to the condition of the equipment. And certainly you can put a dollar value on that as well. So these are some of the things we're looking at. Again, supported by data is always helpful. You'll see in the second model, beyond OEE, how we kind of take a lot of this into consideration and kind of put some numbers to it. So hopefully you'll find that helpful if you need that. And that's more for organizations with lots and lots of equipment. But just to kind of emphasize this point I'm making of the relationship between equipment reliability and inventory. This is actual real data from an organization I worked with years ago. And we have OEE. If you're not familiar with that, it's overall equipment effectiveness. And it takes into account, as you'll see on a subsequent slide, but it takes into account unplanned downtime. It takes into account changeover, quality performance, even takes into account speed losses, because maybe I have to run the equipment at a slower rate because it's not so stable, not in such good condition. So OEE is kind of very inclusive, which is why we like it. Well, if you have poor OEE, low OEE, then there's a tendency for people to have to run bigger batches. Oh, wow, we're up and running. Let's run a lot. Just kind of makes sense. Of course, that ends up being excessive inventory usually. Excuse me. So in this example, again, real data from a company, their OEE was about 62%. And when we did this calculation of what their run size should be, it's just an algebraic equation we will not get into, but if you're interested, just reach out and ask. And it translated to batch sizes equivalent to 25 days of the products that they were running. So at 62% OEE, it translated to you have to run 25 days worth of inventory. So again, that was going to be a main contributor to the amount of finished goods inventory this organization was carrying, right? If you run big batches, you're going to have a lot of inventory. So we said, what if? What if we were able to improve reliability through the application of the various total productive maintenance or TPM concepts, and we could get the OEE improved pretty modestly from 62% to 65%. All of a sudden, they wouldn't have to run such long runs and big batches. They could run about 10-day batch sizes. And of course, their inventory that they're carrying would reduce proportionally. And then we said, what if we got to 70%? Just 8 percentage points. And, you see here, it goes to 5 days, and then it kind of levels off. You kind of get to that law of diminishing returns. So, if you know that your batch sizes can run less, and we can actually calculate the impact on inventory and put dollars to that, we can very easily, if we have the data, make some very informed decisions. And this was one of them. These guys made materials that go in like dentists would use. Now they use amalgams, but back then they were using like silver and mercury fillings in teeth. So expensive stuff, very expensive. They were taking bars of silver and turning them down into dust, basically. And, so we put dollars values on this, and, that was in and of itself enough to justify several $100,000, if I recall, about $100,000 each machine. There was 2 machines, investment in doing TPM properly. And the payback was going to be within months. So we laid all that out, presented it to the senior management. They were saying, of course, we want to do this. Look at what the data says. And I remember the plant manager after the meeting saying, I've been asking for this investment, and spare parts and training and et cetera, for several years now. And they would never approve it. I said, well, did you ever present it to senior leaders with, the data that says, oh, here's what we should be able to expect to gain. This one-time, saving in working capital, that goes right in our pocket. And then the ongoing, annualized savings of cost of carrying, space, this stuff wasn't too space consuming, if I recall. But then just also getting more capacity to make more product if we can sell it. So just trying to emphasize with some data, we can help us not just focus which equipment, if we did this exercise or this analysis on different equipment, and we could see what the financial impact would be. That would, again, inform us on where to start or sell what we want to do to maybe those holdouts in management that don't see this as a worthy investment, which happens still today. Okay. So moving on. I always talk about developing a maintenance strategy, and it's not just let's go improve reliability of identified equipment, but an actual process of creating a maintenance strategy and then periodically, usually annually, updating that. Because I'll mention this on another slide, but it bears repeating. If we can set up a maintenance strategy process, then we can repeat that. And that's what you want to do, because you want to keep this thing going indefinitely. So we want to develop that strategy based on current needs and future business needs, because maybe, again, we see some growth opportunities in certain areas for certain products, which would get us focusing on certain equipment, as well as a look back to the historic performance. And that's where, if we are tracking that, can help us look at the historic performance, but don't overlook forward-looking. That's what strategy should be, looking forward a couple of years from now. That should also be an input to creating the strategy, not just a backwards-looking review of historic performance. We can do a risk assessment, too, to kind of identify the critical assets that are essential to the operation. You'll see how we do that after our review of OEE. And putting some numbers on in a more objective way to determine which are our critical assets. But that requires, looking at potential risks, of failure, the consequences of failure of each asset. And it's an exercise, and as you'll see, it can be a lengthy exercise in the beginning, but it's worth it, especially if you have a lot of equipment, dozens of pieces of equipment, and you just don't know where to start. And I say in the beginning, it's quite a bit of work as you gather this data, set up the templates, the tools, but thereafter, it's much easier. You just kind of tweak and update it each year as you look to see as the maintenance strategy need to change in any way. So again, we'll get back to that more later in the webinar. But very, very basic things like, there's single points of failure. If this equipment goes down, we're screwed. That kind of thing. Identifying those, or where we do or do not have backup equipment available. Looking at the past, we can use OEE as a measure, in a quantified way to help us kind of decide which are critical or not so critical. So let's talk about that next. So as I mentioned, OEE is calculated based on really 3 main areas and 6 areas in total. And it's all percentages. So availability, what do we mean by that? So obviously downtime, breakdowns, that's a component of availability. But setups are also a component of availability. If I'm changing over the equipment or setting it up, it's not available to produce. So that's what we're looking for here. How much time are we losing based on that, those 2 elements. Performance efficiency, and this is one that people overlook. A lot of people track downtime. Not so many, but some track setup or changeovers. But not so many track in a meaningful way performance efficiency. So, we have what we call speed losses, where the equipment's not running as it should, at the speeds it should. And I have to emphasize should, not necessarily the design speed, but maybe for our product, it never should run at what the OEM said, because we won't get the right quality result. But if we did our homework and did capability studies as we should, that would tell us what the the speed should be. And what we would track then is if we're not running at those speeds. So that's speed loss, right? I'm getting lost throughput again because I'm not running at the speeds and feeds that I should. Some folks kind of measure that with their variance reports against standards, but it's usually not in a form that's very useful, to be honest. Too much in there to cloud the issues. And a lot of folks miss, and it's not easy to measure, idling and minor stoppages, where stop and I got to clear I don't want to say clog, but jam in the machine, and I get it running pretty quick. And those idling and minor stoppages can add up in a lot of equipment. That example I showed from the dental materials, lots of idling and minor stoppages. It wasn't always, just downtime, classic downtime. It's down for, hours. So that's performance efficiency. Two elements there. Again, idling and minor stoppages and speed losses. And why I love OEE is it also takes into account quality, right? If I'm making bad product, that is affecting my throughput as well. So we would look at, yields on the equipment. And why I say I kind of like that is if I speed the equipment up, which I've seen people do, at the expense of quality, OEE will catch it. You won't get away with that for long. So it's pretty holistic. So do you measure OEE? I don't know. If you are, how are you using it? Are you just looking at an overall number? Are you looking at the details as this slide shows the elements of it? Because that can help us understand where we need to focus our efforts. Maybe it's not a lot of breakdowns. Our problems are elsewhere, and we would apply other tools, like changeover. So that's quickly is how we calculate OEE. Just another way of looking at it: these 6 elements, 6 equipment-related losses, and gathering the data to calculate those all on a percentage basis, so it all can be multiplied together and give this overall number. At the very least, what people will do is track OEE on a study basis. And by study, I mean a beginning and an end. We'll gather some data, we'll put some observation forms and ask, operators to very precisely track when we're running, when we're not running, when we're idling, why. We give them some maybe predefined, categories so they don't have to write these things down. They just have to track time. And we give them a way of doing that, stopwatches or clocks of some form. If we can get this data off the controller, we'll have to set up the controller so the person can just, all right, machine stopped, push one button, hit another button on what the cause is. We have that all programmed into the controller, and then they can just hit, equipment started again, and, the controller captures how much time elapsed. So don't have to use, kind of hard copy forms, but we got to get the data somehow. And again, it's very often it's just a study with a beginning and an end. More capital equipment intensive businesses track this indefinitely. They have data gathering tools to do it. And the key there is to make sure that the operators, who are really the source of this information, they have to understand what we're doing, why we're doing it, what we mean by the different categories. Someone brought this up in the first webinar, how it's so important if you're going to gather data, the operators gather the right data. Someone brought that up in the first webinar, and it's a brilliant point. So we would, have these out and track the time to get all the data that we would need to calculate OEE. And it just goes into I have a template that I use in Excel, a spreadsheet. You put the data in, and then it, takes it and calculates the different components of OEE. So, the availability and the downtime and the changeover setup, and somewhere in here is the minor stoppages and the quality aspect. So it's got all 6 elements to make up OEE. And it'll calculate it again as a percentage, and then they're just multiplied out to get an overall number. So, a little spreadsheet that we've used for 20 years or so now, at least. More importantly than the number is the detailed data. So we can, same spreadsheet creates these Pareto charts of form if we have all the categories. So here we're looking at the components of OEE. How much are we running? In this case, we're running 39%. Not uncommon to be around 40 when we start. And then the different contributors and what percentage we're losing. So in this case, setup and adjustment, we're losing 16%. Breakdowns, actual breakdowns is 15. Idling and minor stoppages, 24%. And then lastly was the quality loss was 6%. So that helps us focus, our efforts, which is very helpful. And then if we have the downtime cause categories identified, and not just downtime, but the loss categories, I should say, because idling and minor stoppages isn't maybe downtime in the classic sense, but if we have those categories like you saw earlier on the data sheet, we can create some Pareto charts and very clearly see what problems we need to really focus on. So a lot of organizations have, not a lot, but more and more over the years, capital equipment intensive businesses have OEE calculated. They have some nice data gathering systems to get this magic number. But when I ask for the details, like at this level, Pareto charts, I tend to not be able to see that. They don't have this information readily available. They may have, if I back up, they may have this, somewhere. But, this is the actionable information. A Pareto chart for the idling and minor stoppages, maybe a Pareto chart for the breakdowns. Again, garbage in, garbage out. So we have to make sure people are reporting this data in the way we need it to be reported. So that's OEE, very quickly. So looking at history can help. If we have that data already, let's take a look at it. If we don't, I might say, okay, what's your experience tell you, or where we need to maybe collect the OEE data and set it up as a study and see what we learn from that. But usually we, need more and a backwards looking view of things. So, how else can we prioritize? We can, but first we have to define very clear criteria. So things like safety, we can define what that means. We can have like a scale, levels of safety risks. And you're going to see an example of this on an upcoming slide. And put a number to it. And then we can compare the different equipments, what their numbers are. We can look at operational impact. As you'll see in the example that I included in the presentation, it's not like a cookie cutter. What an impact is to you in your organization might be different than another one. Like the next one, regulatory requirements. Maybe you don't have to meet regulatory requirements, so that wouldn't be part of your criteria for prioritizing. So I say we're applicable there. So we would define these clear criteria that allows us to, more objectively analyze and come up with a maintenance strategy. And by having this clear criteria, as I mentioned, it allows us to create a maintenance strategy process that can be repeated periodically, usually every year, or if things change dramatically, we bring in new equipment and things. And that strategy can help us improve over time. If you don't have a lot of equipment, maybe you don't need a strategy. We just kind of experience is data. I always say, in the absence of data, use your experience. And if there's not a lot of equipment or not a lot of complicated equipment, then we can probably come to a conclusion as a group pretty quickly, where we need to start. But if we have dozens of equipment and they're complicated with like a line and it's got 10 pieces of equipment within it, and then within each piece of equipment, there's kind of subsystems, this can get, a little overwhelming. So we just kind of do this very methodical, set up the process for the criteria and how to prioritize, and then we just apply it to all the equipment or subzones of the equipment or subsystems of the equipment, and then we can step back and have, more informed, data-driven decision making. Okay, this will be a little clearer. So here, I pulled this from an organization I've been working with for the last couple of years in the UK. It's a food manufacturer, so they are regulated. So that is a concern or consideration. So we started off with, let's define our kind of scoring system. And they're using AA, extremely critical, assets whose failure will have a major impact on factory production. Maybe more than one line. Because they're a food manufacturer and food safety is added here, product quality and health and safety. Any equipment, when we go through this criteria and this process, comes out to be an A equipment. It's highly critical. Assets whose failure will have a major impact on production, but it's just one line, not multiple lines. And also food safety, product quality, and health and safety. And then B is medium criticality, assets whose failure will have a direct effect on the production and food safety and product quality. And then low criticality, loss of the asset will have very little effect on production. So again, this is not a cookie cutter. We start and say, okay, maybe ABC. Sometimes people want to do AA, ABC. It should never be more than 4. I kind of put the line there. And then we just kind of agree on what it means. What does extremely critical mean to this business? Single point of failure of a very critical line, important to the business, that kind of thing. So we change the wording based on the needs of the business. But we want to have at least 3 and maybe 4 levels that will be assigned to each equipment through this process. This is all part of some big spreadsheet. So now what are going to be the key business factors here? So output, and then we have, ratings. You don't just go, oh, that's about a 2. You have very specific meaning, definition for each rating. That helps us make this subjective activity more objective. So, output, quality, food safety, again, they're a food manufacturing, waste or incidental costs, health and safety. These can change. Like sometimes food safety is not part of it, but even some of the others can change a little bit. And then to peg each number, 1 is no impact, 2, it reduces capacity, 3, it stops the line, 4, it stops all production. We got some kind of thresholds here for quality. If it gets a product score of 100%, it's a 1. If it's 60 to 85% max quality, it gets a 2. If we're less than 25% maximum quality, it's pretty bad. It gets a 4. So I won't go through all of this, but, again, this is not cookie cutter. We agree on the factors, the business factors, and you'll see later, we'll get to the maintenance factors. And then we agree on pegging, what we mean for each number, for each factor. What do we mean by a 1 for health and safety? Trivial risk of harm. 2, tolerable risk of harm. 3, serious risk of harm. 4, major risk of harm. All right. So creating the tools, the criteria, the process really is work in the beginning, but again, you just reuse this. And it doesn't have to change from year to year with rare exception once it's set up. So that was the business factors. These are the maintenance factors. So lost availability. Let's put some numbers on that. If lose less than an hour gets a 1, 1 to 4 hours gets a 2, and higher is worse, right? Higher number means critical. If we're down, 4 to 8 hours, it gets a 3, 8 hours, plus 4. How often does it happen? This is where the history can really help us, like the OEE data or even just other. Again, you don't have to have OEE to do this, but just sometimes it's more qualitative. Well, tell me how often it goes down. Again, experience can be data in the absence of actual data. So this happens more than once or greater than once a month. So it gets a 1. If it happens monthly, we're going to do 2, assign a 2 to it. If it's weekly, 3. This is something that happens every day. 4. Higher number, worse. And then this is UK, so it's pounds, not dollars, but the cost of repair, and we did some estimates with that. So, it goes down, and the cost of repair is less than 500 pounds. It gets a 1. If it's greater than 5,000 pounds or 5,001 pound, it gets a 4. Again, higher is worse. So we're trying to make the subjective more objective. And again, this gives us a way of doing this, and it can be repeated every year, typically. So when we first start this out, we make adjustments to those thresholds. For example, let's say the way we set it up, oh my gosh, 80% of our equipment is AA, highly critical. Well, everything can't be. So then we go back and kind of change the thresholds. And we kind of force it or aim for 20% of all the equipment will be an AA or A. And it's just kind of forcing the prioritization. You know what I'm saying? Because it's really relative. It always is, right? Prioritizing is always relative. I'm going to, just push aside something for something else. So it's always relative. So if we go through this initial analysis, so this is an iterative process. I'll repeat that again, I'm sure. And we get where, there's 53 pieces of equipment at this food manufacturer. And we got 10, ultimately, I think we went through a couple iterations of this, but 10 pieces of equipment, which equated to 20%, were AA, highly critical, and the 9 more were A, critical. So we have 36%. So that's a lot. And, with the scoring system, we get these values. So what we did is we then said, okay, that's the first crack. Let's do it again. And we went back and changed those thresholds to, again, try to force ourselves to prioritize. Where this is in general, it doesn't always hold itself to 20%, but we want the AA and the A to be no more than 20%. Sometimes it's like, Drew, that is what it is, and it ends up being 30. Okay, you just have more work to cut out for us. But we do try to kind of, with this guideline at 20%, help kind of force ourselves to prioritize a little more critically. So hopefully that makes sense. So it's an iterative process that we go through, and usually, 1 or 2 iterations, you'll settle down. And again, that doesn't have to change every year usually. Sometimes if you're bringing in a lot of new equipment and you're taking out of service old equipment, the percentage breakouts can change again, and you might have to rethink your thresholds, your criteria thresholds. So again, what I'm trying to show is a tool, a really good tool. Now, to kind of look at under the hood a little bit more, I just picked a few pieces of equipment. So everything got assigned a number by a team of people, sometimes, most often, supported by data. So this was not like, one session and done. Things like the cost of repair, people were tasked with going to, gather some data to put a number to it, a real number. They had already tracked downtime, so they had a lot of that data. So for frequency, things like that, they had that. So that was easy to assign numbers here for the different factors, whether it be the maintenance, business factors or the maintenance factors. But you get these numbers and you multiply things out and you get, based on the criteria, what the criticality is. So again, it's kind of looking at the thresholds to get what defines AA versus A. I don't know if I was clear on that. Let me back up. So right now, maybe the threshold to be an AA is going to be even higher than what we originally calculated it to be, given all the factors and the scoring system. So we might tweak these a bit and/or the thresholds. But let's say we settle in and say, okay, it is what it is, and we get this factor, based on those thresholds of what makes an A, what makes an A, what makes a B, and what makes a C. And again, we want to focus on the AAs first and then the A's next. just kind of multiplying out those factors. Now, again, some pointers for setting such a tool up and process. This is a small group activity. It's not just engineering or not just maintenance folks. It's engineering, maintenance, the operations people are involved in this, quality people. In this case, regulatory people were involved in this. So we're, drawing on the collective experience of that team to assign the ratings, the levels. Again, we supported by data where we can. Try to use the full range of possible scores for a factor across the plant. What we mean by that is, score everything in the beginning. Doesn't mean we're going to address it. And then we can go back and tweak and adjust. So, for example, if a score is not assigned, I don't have any B, I don't have what the tendency is, that doesn't apply, and we don't try to put a number in for everything. Sometimes it's a little bit of a stretch to apply some of the factors, but you really want to, because what ends up doing is you throw off the scoring system and you're not comparing apples to apples between equipment. All right. Consider, the equipment under normal operating and breakdown conditions. Don't think of worst case scenarios. By that, when we're thinking about what's the frequency, it happens all the time. And then you look back, it's happened a lot in the recent week or two, and that's what's in the forefront of people's minds. So they tend to want to score it that way. But when you look a little more in the history, it's not so bad. Humans are funny. They'll remember the most recent thing, recency bias, and they always tend to think of the worst case. Like, well, how long does that go down? Once it went down 20 hours. It should get a 4 for that one. It's like, well, hold on. Once, when was that? 3 years ago. Let's look, more at a bigger data set. Okay, a bigger data set. So when we go through it, we try not to get too hung up. People get a little too hung up. I said, let's just get the score, because it's going to be an iterative process. We're going to go through this again based on what the results are. So don't get too hung up, and so move quickly. And again, that 20% for AA and A's, or if you're just doing A's, is a guideline. Sometimes it's going to be a little more or less, because if people can make a case, no, Drew, we're not taking that one out because, and it ends up again being, say, 30% of total the equipment are AAs and A's, and so be it. That's okay. But we just want to try to force ourselves to prioritize. Okay, I'm talking about organizations with dozens of pieces of equipment. If you only have a few pieces of equipment, you do not have to do this, unless you want to. Okay, so we do the exercise. We agree on the scoring tables. Don't be changing the factors. Let's change the factors, because again, you throw everything off. So that's why there's a lot of good discussion of what the business factors are, the maintenance factors, the levels for those, and then we can move on. And usually it's just a matter of changing the threshold for what is an AA and what is an A. Once in a while we go back to the levels and maybe tweak those a bit. But it's more of just the thresholds for what constitutes an AA or an A. So that's how we kind of do it. I don't know if you find that interesting and maybe helpful. Now, another thing that we look at is FMEAs, or a form of it, failure mode effects of criticality analysis. I don't know if anyone's familiar with this, but we would do it for each critical asset. So now I've got my AAs and A's. Now we're going a little bit further to drill down. And, we've got some criteria for occurrence, the frequency. We've got some levels here, a rating system of 1 to 10. Again, always have definitions for these. So what we mean. And I usually, give them a starting point. Frankly, most of the time they kind of stick pretty close to what I got here. But sometimes they'll tweak it. And what we're trying to do here is get, again, a more objective way, what is called an RPN, a risk priority number, which will help us prioritize potential failure modes on that critical asset. based on current frequency of occurrence from the past and severity, the impact severity. So, at this food manufacturer, they've got big, long lines, complicated equipment. Now we're focusing within that equipment. What do we really got to focus on and apply our TPM, concepts to those elements of that complicated equipment. So we've already got the AAs and A's defined. That was what I covered up to this point. Now we're picking a single asset, critical asset, and drilling down and looking at the failure modes and the criticality of those. And that'll help us make even more decisions. We'll get these RPN values for A. This is for a machine and all the different components of it and the different, components that can fail in different ways, these subparts here. And we're getting these RPN numbers, which can give us clarity on what we need to focus on within that machine. Okay. And I'm a biggie on process because you can repeat processes. And once we set up this scoring system and get and have the data that feeds it, those processes set up, then it becomes a regular, usually annual exercise that cross-functional team I described earlier will go through. Other new things can happen, like any strategy changes in the marketplace. So what was a business factor for a machine might have changed. Maybe the market is dried up for the product that machine ran. So you got to refresh this, like any strategy, no different than a business strategy, has to be refreshed periodically and usually no less than once a year. So that things can change, but you basically just kind of repeat the exercise, So we've got about 10 minutes or so. So I'd like to hear, from all of you, not just what questions you may have, whether it be OEE or this more advanced kind of rating system to help prioritize, but maybe what your organizations have done to figure out and answer that very important and basic question: where do you start with a total productive maintenance effort? So if you could, please put in the chat any questions you have or any just examples or what you are doing on this subject, either starting it up or maybe you have a mature system and you're years into this, and maybe you can discuss how you found this process or something similar and the development of a periodically updated maintenance strategy, how that's helped your organization. So hopefully we get some good sharing here. Session one went pretty well. It just took a few moments for people to type in. So we'll give it a few minutes. And of course, any questions you might have as well. We went over OEE. We went over this criticality calculation, and then we also did go over failure mode, affecting and criticality analysis. Kind of three tools. Do we still have people on? I hope. No questions. Nothing to share. That would be remarkable. I usually get lots of questions about like the spreadsheet tools. There we go. Sean, thank you, Sean. Great presentation. As a manufacturing consultant, when working with companies who have never used data, having them identify the top 5 failure modes is an easy place to start. So I assume you're the consultant, Sean. Yeah. especially, like saying in the absence of data, experience is data. That's how I always refer to it. So going around the room with the right group in the room, not just, again, engineering or not just maintenance folks, but good cross-functional representation, we can prioritize, especially if it's not a lot of equipment. That food manufacturer had over 50 pretty complicated pieces of equipment. Anyone else have anything to share or suggestions? Here we go. We only have big lines. Yes, that's kind of like the food guy. And we just did a quick risk assessment. And our biggest issue, we didn't have any parts on the shelf. Spare parts, I assume you're referring to, Desmond, right? I would assume. So you got data now to justify going to buy some spare parts, right? Desmond, if you could, when you said you did a quick risk assessment, was it quantified in some way? Maybe not as involved as the process and model that I showed, but was it quantified in some way, your risk assessment? That was a question for you, Desmond. I was just curious. Maybe Desmond's not there. Or did you guys just kind of, hey, kind of back of the envelope risk assessment? I was just kind of curious. Sean's asking if some of the visual tools are available. Definitely the OEE. I can send a spreadsheet to Rose and she can make that available to people. Just remember, any of those tools have to always be tweaked a bit. The other one, I have to think about that one. It's not mine to give you. If I kind of scrub out all the company information, maybe, but let me give that some thought. So Desmond, not sure what you mean by that, but we just went over different failure modes. Okay. So you kind of did a FAMICA of form and what we can do to shorten downtime. So maybe not so quantitative, it sounds like. Just kind of listed out the failure modes. Got to start somewhere. Right? Nothing wrong with that. Got to start somewhere. I do not do that very involved criticality analysis on companies unless they have a lot of equipment, dozens. And it's not clear where to start. Does seem to resonate with like the engineering folks supporting the equipment. They kind of like it. Any other questions or sharing that anyone on the webinar would like to do? How you went about prioritizing, or how you went about using OEE even? Did you find it helpful, not helpful, a waste of time? I've had companies tell me, we don't do OEE here. And I'll say, well, so you don't want to understand the sources of your downtime so you can act and continuously, improve on them? Oh, we want that. So I was like, well, tell me about your experience with OEE. And usually it was a bad experience. Either they didn't use it because they didn't get to the detail level, or it wasn't understandable because they weren't presenting the elements of it, the components of it. They were just presenting this one number, which is nice to have, but really it's not actionable. Or it was just too cumbersome to gather the data, even as a study, for a set period of time. So let's see how we are doing on time. No more sharing? Anyone else besides Desmond and Sean? Thank you very much to the two of you. Okay. So what I will do, Sean, I'll send that one spreadsheet to Rose, and she can, at SME, and she can, whatever, make it available to you all. And the other one, I have to think about that one a little more, if I can scrub it. It's so, specific to companies, that the criteria. So maybe if I scrub it a little bit, I can give you something. don't know how useful it'll be. Okay, so I guess that's it, Rose.
Sounds good. Thank you, Drew, and thanks everyone for joining. Look forward to seeing you on the next webinar in 2 weeks. Thank you very much.
Thank you all. Have a great 2 weeks.